and then it, you know, with a hole at the top and some sort of outside air line that's connected to a out a window, you know, whatever, a hole in the wall, whatever it may be. This is the only way I'd do it. Okay guys, I reconfigured the J-tube a bit, trying to come up with the best solution possible if anybody wants to build this. So I'll break it down when the test is done. A little more room for the flame, a little bit bigger J-tube. I've made a little bit of like a, I don't know, you might call it a port, but it's not really like a batchbox port. Some bricks in the back squeeze it down to create some turbulence. And there almost always no smoke out the chimney. The only problem with the rocket stove is sometimes you get some smoke coming up out of the top. Okay guys, 2 videos back is a major talk on the advantages and disadvantages. There are some incredible advantages to the J-tube rocket stove with the barrel over top and the thermal mass. There's some huge disadvantages. That's 2 videos back. I won't touch on that as much in this video. There are some reasons to make this. There's some people might still want to make this. You could make this work, but if I was going to do it in my house or my homestead, this is exactly what I would build, and I'll show it to you. I'll break it down. The bricks you need the full-size fire brick at 9 inches by 4.5 by 2.5. Correction, 70 fire bricks. There, as far as I can see here, there's a little bit in the middle we could talk about cuts. There are no cuts, no wet saw cuts, no angle grinder cuts. That is another reason many people will build this. 0 cuts for this stove. I'm covering the bridge with a metal plate. No doubt its greatest advantage is burning the bottom of the sticks and only the bottom of the sticks. I mean, these have been in there for, this is from my old wheelbarrow. This has been in there for, it's been in there for 10 minutes. Just burns the bottom. Okay, the only way I would do this in my house or my homestead is to, once the fire gets going, the big disadvantage, if you didn't watch the 2 videos back, the big disadvantage is eventually it'll start to smoke up. A stick will burn high, it'll start to smoke up. You have to, at the very minimum, you have to, you know, this is too small. You have to choke this off with a piece of metal. With a big piece of metal and you just have a thin opening, of course, very, very little, if anything, nothing will really come up. But if this was going to be in my house, this obviously is not a metal box. This is, I figure this chewy box would be close to what we need. This is the only way I'd do it in my house, an outside air line. You get a metal box, have somebody weld it together, fits over, I'm going to have to come back, guys, fits over the top. Okay, so some sort of a metal box, whatever. I mean, it's not going to get that hot. It could be even aluminum. And then it, you know, with a hole at the top and some sort of outside air line that's connected to a out a window, you know, whatever, a hole in the wall, whatever it may be. This is the only way I'd do it. Once it gets going and you put your outside air line on so it's not taking the heat from the house, there's no way gases are going to, you know, if everything is sealed up, there's no way gases are going to come into the house. I like it, but you need something pretty simple where, you know, you could just, obviously, this is so tight, my box on the, something you could just like lift off, check it, you know, add some wood, and then just throw it back on. So, you know, I don't know what this is or even why I have it, some aluminum. I'll probably end up using it for an outside air line, just feeding it up to my wood stove at some point. But this is the only way I'd do it. If I had a super drafty homestead or, hold on, super drafty cabin or something like that, and just tons of air, not sealed, hard, you know, not great insulation, no new windows, you'll get some smoke when you start it up, but you put a metal plate on, and once it's going, I watched it very carefully, you know, and I even put paper, lit paper. There's no smoke once you seal it off like this. there's no smoke that comes up here. It's just when you take it off to add wood, you're going to get smoke. Because it's two competing chimneys, like I said in the other video. Two competing chimneys. Of course, this one outcompetes this one by 96 or 97 or 8%, but if you know, every once in a while your sticks start to burn up. Create something like that. Now the flame's coming up. Now all we can do is experiment. Seems like it's coming up more with that. Let's try that again. Maybe because that piece lit. That little piece lit at the top because of the heat. Let's see what happens. Does it make it worse? I don't know, we'll record and see. It seems to be coming up more. Interesting. Try that one more time. Yeah, that's worse. Wow, look at that. It's worse. Flames up. Get rid of that damn thing. Okay, some smoke puffs came up with nothing. Okay, let's try this. Let's try. Ooh, it doesn't like that. Listen to that. Hopefully from the front. I guess you could live with that. Just have a piece of metal, keep the front open once you get it going. I don't know if you guys can see me or what, but I ain't got no professional photographer, but of course this is a rocket stove barrel. I got this for 10 bucks at a scrap yard. To make a rocket stove J heater, you just have to, you put your 6-inch stovepipe. I think I cut this out with a metal blade jigsaw. Drill 8 to 10 holes with a cobalt bit. Get some holes bigger and then get your jigsaw in there. Okay, if you're going to build one of these, this is the most important part, the measurements. I believe this is a standard 55-gallon oil drum. Millions of them should be all the same, but I don't know. Check your measurements. Some of them are a little bit different. So I can only do if you get the same size fire brick and barrel as me. That's the only way it's going to work for you. You can't see that, but I've checked it on the side many times. 33.5 from the ceiling of your rocket stove to the bottom of the barrel. You're going to flip it upside down. 33.5. Okay. So I've taken some of the bricks out here and turned one on its side. This will be the top of your shelf for the barrel. You're going to build either with stones or pour cement. I'll show you what the options are in a minute. At this level, you're going to build a base to hold the barrel as you turn it upside down over the riser. Here's the key. 2 inches between the top of the riser and the top of the barrel. 2 inches. And back in the day, I've heard people get away with 1 3/4 inches. It's a little too tight for me. If it's choked off, nothing's going to work. However, don't just say I'll put 3 or 4 inches up here, 5 inches. Too much space between the top of the riser and the barrel will hurt your draft. It will hurt your draft. It's better to have it tight. 2 inches seems to work for everybody. Now, how do you know? Because, well, this is the best math that I can come up with if you use my configuration, but I'll show you how to make it foolproof in a second. If this here will be the top shelf for the barrel as I turn it upside down, and then I'm going to make if you want to build this, you will have to make a shelf with concrete or stones for the barrel. So here's the math on it. Okay, it's only 29 to the top, so that's too much space, right? You need 33.5. However, you've got to account for, what type of mortar are you going to use in your joints here? If you use refractory mortar, You know, you're supposed to put that on incredibly thin, 1/8 to 1/16 of an inch joints if you use a refractory mortar. So how much will that build your riser up? Look, you can get away with, so here you have way too much space, but the riser is going to get bigger as you add mortar. So look, 2 inches is good. 2 3/4 inches is fine. I would not go over 3. You're going to lose draft. So you might have to, depending on what mortar you use and how tall this riser gets when you add mortar, you might have to adjust the level. Just keep that in mind of your base. Okay. Now to make it foolproof, you can do this. Hold on. This is about 2 inches. I didn't assume I cut 4 little pieces. You just put in wooden spacers on the corners. Flip your barrel over, and then maybe you still have a 1/4 inch down here. Your barrel is suspended in the air by a 1/4 inch. You could just pack more cement, or however you're going to seal the bottom of the barrel. Put your spacers in up here of whatever you want. And put wood in. You know, they'll smolder and they'll catch on fire and they'll eventually go away on your first burn. But then you'll know, you know, assuming you left a 1/4 inch down there, you can then at the very end you can pack that and pack the sides of you know, however you want to do it. So put your spacers in. That works. Let's do the smoke test. There you go. Look, if you have a piece of metal across, it makes all the difference. But you can't leave it open. It's too much smoke is going to come out every so often. There's no wind out here. 0. There you go. 0 wind out here. Use the big double wall insulated pipe just to establish draft in the beginning. Bricks are ice cold, wet. Not needed. Let's see how if the draft changed. Yeah, it really did. That insulated pipe made a big difference in terms of the draft. It's coming up now. Still no smoke. Okay, building the base for the bottom of your barrel. I believe I have a standard 55-gallon oil drum here. You check your measurements. I believe mine's very standard. There's tens of millions of these. It's 23 inches. Just a tad less, I believe, across the bottom. 23 inches. Check your measurements on whatever you get. So, hold on. Gotta pull out my tape measure here. This is how I would build my base. You could use stones or whatever, but you make something, you want to make it nice. This is just 23 inches. So the base of your rocket stove is 14 fire bricks. I'll show it to you as I break it down. 14 fire bricks. So then you would get regular bricks. There's no need to buy expensive fire bricks. Regular bricks on their side. These are 4x8 pavers. And with your mortar joints, there's your 23, but with your mortar joints, you're going to be, even though your joint should be very, very tight, you should be 23.5 or 23 3/4. So then, that's enough width. You just build a wall as high as you need to. Remember, so you have that 2-inch gap between the top of your riser. Obviously, I've taken bricks off. This is not how high the riser is going to be. I'm breaking it down. And so I would build, and you're going to have to come out here too. I don't know how far. You're going to have to come out here and build this up. And then in this space, I would I have to think about what mix to use. You don't want to use just cement and just concrete. You want to mix it so it's a little flexible. Let me think. But you pour your mortar in the gap. That also insulates the stove, makes the stove hotter for better combustion, higher temperatures, etc. Okay, it's a little off, but centering it would be about there. There's a ton of room between your riser and the outside of the barrel. Tons of space for the air to get down. It could be much tighter than that. And you're going to be using this brick configuration, you're going to be pretty close to your front riser. That's fine. That's fine. Of course, you're not going to set your barrel just on 2 bricks up from the base. Remember, you're going to need to build that center area up so you have your 2-inch gap at the top. However you decide to do that, depending on how much mortar you use in the riser. It's going to end up looking something like this. And of course, this, where you have your pipe, the 6-inch stovepipe will come out there. Will depend on the next phase, will be where your thermal mass is and what you're going to use. People use the cob bench. I like a brick box, a big thick brick box. We'll talk about that. But this could be on the side. You could have your pipe coming out into your thermal mass on this side. You could have it facing the back. You could have it facing that side. So that is up to you. It does not have to come out the back. It could come out the side. Okay, what you pour in the space, you could even use stones, but I don't like that because the gases, gases are going to seep down. If you use stones, your top inch needs to be cement. You could use stones, but just the top 2 inches. But I would, to make it look nice and make it, even use the surrounding, this is actually a good height. That's kind of where you're going to need to be. I'm not sure how forward you'd want to take that. I probably would take it to the end. And then of course it needs to be around the back as too, to hold the back of the barrel. So I would use, if it was me, I'm no expert at this, but I think you want it to flex. You can't put in cement or concrete. These bricks, these fire bricks will expand and they will either crack themselves or they will crack your cement. I think, okay, adding this, I changed my formula a bit to 5 parts perlite. I'll show you that stuff in a second. 2 parts sand, 2 parts dirt, 2 parts cement. Type S, or you could use concrete with the stones. 5 part perlite, 2 parts sand, 2 parts dirt, 2 parts type S cement or concrete. 5, 2, 2, 2. It has to be firm to hold the barrel. Doesn't need to support any real structural weight, but needs to be spongy. Needs to flex a bit. Many of you are going to be better. This formula will work, I think, but I'm not an expert. It has to flex. Okay, this is perlite. You can get it at most garden stores. It's easy to order online. I got this years and years ago. People use this sometimes as an insulation in their riser. If they use a stovepipe riser, like a 6-inch pipe inside an 8-inch pipe, they might put perlite in the space between. It's good at 3,000 degrees. It's super light. It's easy to work with, and it mixes with mortar very easily. I think just this, it's like $3.50 or $4 at Home Depot, the 40-pound bag of the cheap topsoil, not the Miracle Grow stuff, that's the super cheap stuff. Fill holes. The dirt in the perlite will flex. Okay, let me continue to break it down. You can see that the burn chamber to get from riser to riser is 2 fire bricks high on their side, and then since the fire bricks, this doesn't, it's kind of odd size. Nothing fits in here. You want to just use a piece of metal. You can get 22 gauge or 20 gauge steel sheets at any hardware store, and that cuts with regular snips. Use a piece of metal, put the metal underneath, and then of course you're putting 3 or 4 inches or whatever of cement on top, or that formula we just talked about, you're putting on top anyway. So there's no gases can possibly get up. Okay, each riser is just 4 in that configuration. So let me just get rid of these and see. Each riser's built, they're built independently of the main structure and of each other. I decided to put it's two fire bricks tall on the side, your burn chamber here. I decided to put these in it basically almost creates like a batch box port to a degree. That this is your large riser. If these aren't in, is it the end of the world? It's probably going to be smoke free. It's probably not. It's probably going to be just fine. I've never seen anybody do this, but I have. It's just, maybe it's my pet peeve. I've seen when gases and flame and smoke is allowed to pass too quickly through a system, you can get smoke. I like this for some reason. I just like putting those two in there to create turbulence. It's a little bit like a batch box port. It didn't seem to affect draft at all. I would do that if I was building it in my home, but most people, I've never seen anybody do that. Okay, now we have a base of 14 bricks. It's just one butted up against one. 1, 2, 3, 4, 5, 6, 7 long, 14 total, and then each one here is 8. 8 on top of 8. So 14 on top of 16, 30 bricks just in what you see there. Total would be, should be about 70, right? Okay, each riser is just 4 in that configuration. So let me just get rid of these and see. Each riser's built, they're built independently of the main structure and of each other. I decided to put okay, it's two fire bricks tall on the side, your burn chamber here. I decided to put these in it basically almost creates like a batch box port to a degree. That this is your large riser. If these aren't in, is it the end of the world? It's probably going to be smoke free. It's probably not. It's probably going to be just fine. I've never seen anybody do this, but I have. It's just, maybe it's my pet peeve. I've seen when gases and flame and smoke is allowed to pass too quickly through a system, you can get smoke. I like this for some reason. I just like putting those two in there to create turbulence. It's a little bit like a batch box port. It didn't seem to affect draft at all. I would do that if I was building it in my home, but most people, I've never seen anybody do that. Okay, now we have a base of 14 bricks. It's just one butted up against one. 1, 2, 3, 4, 5, 6, 7 long, 14 total, and then each one here is 8. 8 on top of 8. So 14 on top of 16, 30 bricks just in what you see there. Total would be, should be about 70, right? One very important thing I forgot to mention when I was doing the video outside, if everything is perfectly square and you're one of these, complete neat freaks when you build your masonry and everything's perfect, there'll be no way to lay this brick across when you build your independent risers. There's no ledge if everything's perfect. Don't try to make it too perfect, guys. If you're going to go through the trouble of making this brick here, for example, just pull it a 1/2 inch over. Don't make it, and so what if it impinges a little bit on the size of the burn chamber? It creates turbulence, and it's no big deal. Do not try to pull it over 1/8 of an inch and just have a little bit hanging on, and it'll fall apart. Pull this over a 1/2 inch, create a nice ledge, or do whatever you need to do. It's probably worse this brick being pushed over this way. You could create a 1/4 inch here, and then you could pull this one a little bit this way. So you'll need to do that, of course. It will not stay. There's no ledge. But don't try to be too cute. So what if it looks a little off? It's better the damn thing lasts for 20 years. Create a nice 1/2 inch ledge. This section on the thermal mass, guys, is next, but let me get this in here quickly. Anybody that has any sort of rocket stove should keep a tub or two of this on hand at all times, or like $7 or whatever. It's just too useful. For example, you have a 1 foot or less 6-inch stovepipe coming out of the barrel going into your thermal mass. That's the idea I'm proposing. You need to cake this stuff around where it goes into the mass and where the pipe comes out of the barrel. Cake this stuff around to make sure no gases come out. It's good to 2,700 degrees Fahrenheit. It's not very strong, but it is good for this use. You just put your rubber gloves on and you just cake it around. You cut out your barrel, you're going to have it's not going to be perfect. You need to cake the difference between your stovepipe and your barrel, as well as where it goes into the mass with this stuff. Build it up. I think it needs to be cured a bit too. It's not clear in the directions. I always take like a butane torch to it a little bit when I was done to kind of cure it a bit, or just put it on maybe one day before I do my first firing. A lot of high temperature refractory does need to be cured, and for some reason, the manufacturers are often unclear on that. It's totally bizarre, but get this stuff. Okay, the second part of a rocket stove system, of course, is the mass, the thermal mass, the weight that will heat up and then radiate heat out for, depending on how big your system is, 6, 8, 10, 12 hours or more. I think people try to do too much with the mass with these rocket stoves. And I like a simple brick box over. This is not a rocket stove. This is just an example I'm going to show you taken from it's a large Russian masonry heater that pushes the exhaust down through a bench before it goes up and out. But the same principle applies in terms of what I would do if I was making a J-tube rocket in my home. Don't understand these big mud benches. I don't get that. And how big are these people's homes? How much mass do you need? It's like most people that do a J-tube, aren't they living like in a real small little homestead? So if you have a rocket stove, the barrel's going to create tremendous heat immediately, like a wood stove. If you then right next to it have a relatively small brick box with 1,500 pounds, that's going to be a lot of mass. So here's what I would do. Assume, I'll show you a little bit more of this video, but for this, guys, assume this whole part is not a masonry heater or a Russian stove. This is the barrel and the rocket stove part and where you feed your wood. Just pretend. And then I would simply have a brick box, as long as you can, but not ridiculous, like people go down 14 feet. There's no point. How big's your house? And, if you put just a 1 foot section of stovepipe coming out of the circle cut in your barrel. I know some people do it a different way. We'll talk about that later. With the way I've designed this rocket stove, your stovepipe coming out of the hole cut in the barrel is pretty high. So fine, it would go into a brick box or a brick bench. Maybe it is a little bit high. What you can do here in terms of winding the gases around depends on how good your chimney is then going up and out of your house. If you have a 12 to 15 foot run of chimney going straight up, that's insulated, that's double pipe, that's a 8-inch pipe around a 6-inch pipe, insulated with mineral wool, it's going to pull like crazy. You can do a longer bench, you can wind it back and forth. It depends. Do not do what a lot of rocket stove people do. If you're going to use mass, you can't just put a little pipe straight out the wall. That does not work. It might work. It'll work great when the flame's raging inside the barrel. Just huge flames, and you have all this engine working for you. But once things start to cool, it's unsafe. It can back up. So depending on what you can do here, is number one, do you have a 12-foot chimney that's insulated going straight up that's going to pull like crazy? Or do you have a chimney going up 3 feet and then out the side of the house and then another 5 or 6 feet in the ice cold? That's a single wall. That's not going to pull real well. That's not great. So I'm going to assume you don't have some $5,000 chimney system. I would simply create a simple brick box. Not winding this and that or back and forth. No, I would just create a brick box, 3 bricks wide, 4 bricks wide, whatever. And I would put cinder blocks in it. I would at the back end, I would create a little bit of a wall. So your gases You're not going to have this, this, what I think of this BS I constantly hear about, stratification chamber, stratification, and bullcrap. We'll talk about that later. If your chimney was here and your rocket stove was here, and you have just a 10-inch section of 6-inch stovepipe feeding the hot gases from the barrel into the mass, just a brick box, then right about here, don't, leave a 3-brick opening at the bottom. So your gases kind of have to kind of stay here for an extra second before they have to go under the little wall and up the chimney. You can, if you have the great insulated chimney at 12 to 15 feet, then you can block it off more, because this thing's going to pull like crazy. You also might need a way, depending on your system, to get this chimney warm before you start the rocket stove. You put a little clean out door here in the brick box, in the brick mass. Start a little paper fire with some kindling. Get that chimney at the end warm. And that will then make your whole start of the rocket stove much easier. If you do a big mass, some people's system, it works right away. Other people's don't. It backs up and smokes for a while. Depends on how tight your house is. A lot of things. And people say, well, Matt, don't you have to wind the gases down and don't you have to have your stovepipe right next to the barrel? No, it doesn't do much. It might keep your chimney, if you have a single wall stovepipe chimney, it might keep it warm for 5 more minutes. It's not a big deal. You can have your pipe. I would have my chimney down the end, but wherever you want to put it. Wherever you want to put it is fine. So if it's just an open box, if it's just an open brick box, mass, you want to get to 1,000, 1,500 pounds minimum, or it's not really going to absorb and radiate out much heat. I'd put, regular cinder block, which is really concrete block, is open, very open. You could just place a bunch of those in here. That just adds another 800 pounds of mass. Concrete heats up really quickly. It holds heat. Concrete doesn't like 1,000 degrees or above. It breaks down. But in terms of absorbing heat quickly and mass and rate, concrete and cement is great for that. So I would but when you, obviously, tons of channels and tons of ways for the air and the smoke to get through. Don't place your concrete block or your open cinder block in ways that could choke off the gases. I guess that's it, guys. People do too much with the mass. I don't understand why all that 5,000 pound cob bench is necessary. I don't, whatever. Does the stovepipe, like the cob bench, does the stovepipe run through here? No, it's just gases in here, just gases. So make sure you have a double layer of brick on top to be safe. You want gases coming out. People run that pipe through the cob benches, and I know obviously 1,000 people have done it, so the cob bench eventually gets nice and warm. But it would take a long time. You just dump your gases out directly into the brick box. It could be a brick box going. It doesn't have to go long and low. It could go up. It could go 8 feet up in the air. It could do whatever. It could look. As long. If you have a great chimney though. Whoops! I started this. You could. If you great pulling chimney that you've preheated, you could wind those gases a little bit. Let me bounce around here just to show you. The bench, he's creating a channel, so the gases will wind down here, go around the corner, and come back. And you see this a lot, even in rocket stove designs, and that's great. But I only like that when you have a really long insulated chimney that pulls. Here's you see this all the time. Gases go down, go around the corner, and come back. And if your pipe's here, I love this, but I don't love this if you have like a 2-foot rise, a pipe that goes up, and then 1 foot through the wall, and then 5 feet up in the ice cold single wall. As things, it's gonna be fine when the flame's just raging. When things start to cool down, and you just have coals, it will slow down or back up, and I don't like it. don't like it. I guess I'm being repetitive, so I hope I've got the point across to you. Don't try to do too much with the mass. You know, you should. Don't you have a little home anyway, with a little cabin or whatever? What do you need? What do you need 18,000 pounds of mass for? Anyway, being repetitive. Thanks for being here, guys.